Hi everybody. So what we're going to do is we are going to return back to section 1, and I just wanted to give you an apology. I thought that I could be smarter than the book, and I thought that I could put everything into a better order, and now upon review I'm realizing I should have just stuck with what the book was doing. So I'm sorry if it feels like we've been jumping around a bit. Hopefully this isn't going to be too confusing, but I think in this lesson though you'll be able to understand it just fine. We're going to be talking about the special right triangles, and so we're going to be taking care of all four of these points here. So the first thing is we're going to talk about the 45 45 90 triangle. So you should recognize that not only is this a right triangle, but it's also going to be an isosceles triangle. And what we're going to do is we're going to find the hypotenuse, and we're going to use the Pythagorean theorem in order to do that. Now the book uses x. I've chosen to use d just because I don't want this to be confusing when you're trying to solve questions later, and then you've got multiple x's floating around and you're not sure which x is which. So instead, we're just going to use the letter d. So I'm going to use Pythagorean theorem. We know that that's going to be then d squared plus d squared equals, and I'm just going to put question mark squared. And we're going to try to find what that hypotenuse is. So we're going to combine these together, and we're going to get then 2d squared is equal to the question mark squared. Then we're going to take the square root of both sides. And what we will get over on the left side is going to be square root of 2, and square root of d squared is equal to the question mark. And then finally, when we simplify, we are going to get square root of 2 times d. So that means then that our hypotenuse, I'm going to rewrite it just slightly, our hypotenuse ends up being d square root of 2. So that means then that for our sides, the ratio that they are in, we are going to have, well, down below I'm going to put d, and d root 2. But notice that if we happen to divide all of the d's out, then that leaves us with this ratio 1, 1, square root of 2. And by the way, now would be a good time just for you to know that the square root of 2 is going to be about 1.414. And so that's going to be helpful because the hypotenuse is supposed to be the longest side in a triangle. So that will help you remember then that in the right triangle that the hypotenuse has to be square root of 2, whereas then the two congruent sides are both going to be 1. Okay, in this question then what we have, we are told that the length of the hypotenuse is 24, and we need to find then the length of either leg. So I'm going to write in the 24 there. And then from the triangle on the last slide, we just found out then that we have d there, d, and then the hypotenuse is d square root of 2. So in order to solve and find the lengths, what we're going to do is we're just going to make an equation using those two values right there. 24 equals d root 2. Then we're going to divide both sides by square root of 2. And what's going to happen when we get 24 over square root of 2 is equal to d, we need to rationalize our denominator. So let's multiply the top and the bottom by the square root of 2. And now we are going to have 24 root 2. Remember, square root of 2 times square root of 2 becomes square root of 4, and that simplifies then to become 2. And then the last part is we can simplify. 24 and 2 cancel. That becomes a 12. And so our legs, we're going to have a length of 12 root 2. And there you go. So what I want you to do then, you are supposed to find the value of x in this picture. Remember what values you're supposed to use for the three sides. Pause the video, and then when you are done, I will demonstrate how to solve it. Okay, so now that you are done with this, once again, we know that the two congruent sides in this isosceles triangle should be labeled as d, and then that's going to mean that the hypotenuse has to be d root 2. So right now, we already know 2 is equal to d. That's easy. So then all we need to do to find x is we just need to put 2 in for d. X is going to be equal to 2 root 2. So this one wasn't too bad. All right, and then the trig ratios that we have for the 45, 45, 90 triangle. So if we have sine, now it doesn't matter which of the angles we use because they're both 45. So I'm just going to go ahead and cross off that one, and I'm just going to say, okay, we're going to use this 45 down here. So for sine, if we need opposite and hypotenuse, so we're going to label our three sides, opposite, adjacent, hypotenuse. Sine is going to be opposite over hypotenuse, d over d root 2. But then we should simplify that. We can get rid of the d on top and bottom. So now we are left with 1 over square root of 2. Some textbooks, some websites are going to leave it as 1 over square root of 2, but I want you to be aware that there is a ratio that is far more common. So if we were to instead multiply the top and bottom by square root of 2, so we rationalize, then that is going to give us square root of 2 over 2. And this is going to be a very important ratio, not just for this year, but when you get into IM3 and then AP Calculus as well. You're going to see that ratio very often. All right, now the next one that we have is cosine. So cosine of 45 is adjacent over hypotenuse. We're going to get d over d root 2 again. And this time, we get the exact same thing, 1 over root 2. So it turns out that cosine of 45 is the same thing as sine of 45. And now our last one, tangent is the opposite over the adjacent. We get d over d. We can see that both of those cancel. And we end up with 1. So that's an interesting value there. Tangent of 45 will always be equal to 1. And that makes sense too, because if you look at our sides, opposite and adjacent are always equal to each other, so yes, the ratio for those two should always be 1. Okay, now we're going to move into the other special right triangle, the 30, 60, 90. So for this one, what we're going to do is we're going to start with an equilateral triangle here on the left side, and we're going to cut it in half. So, oh, that's not very good, but I'll fix that. So there we go, that's about half. Now remember that in an equilateral triangle, all of the angles are 60 degrees. So up here at the top, we've just cut that 60 degree angle in half. That's how we're going to get the 30 degrees there. Now if we had D on the bottom, we've just cut that in half. So now the bottom is 1/2 D. This side here is D. And now we need to use Pythagorean theorem to find what that missing side is. So we're going to do question mark squared plus 1/2 d quantity squared equals d squared. And then we are going to get the question mark squared plus, this is going to become 1/4 d squared equals d squared. We're going to subtract the 1/4 d squared from both sides. And that's going to leave us then with 3/4 d squared. Here we will do the square root of both sides. Now the question mark is square root of 3/4 and the square root of d squared. And then finally, finishing it off, this square root of the fraction, we can do the square root of 4, so we know that the bottom is going to be 2. We can't do the square root of 3, so it's going to stay. And then square root of d squared is d. So it turns out that the missing side in this was going to be square root of 3 over 2 times d. Now, the last part, though, is that this is not the common form that you're going to see for a 30, 60, 90 right triangle. Rather than root 3 over 2, 1/2, and 1, which is going to be multiplied by d, instead what we do is we multiply every single one of them by 2. And when we do that, instead of these values that we had before, that will give us then d in the bottom, d root 3 is the height, and 2d as the hypotenuse. And those are going to be the values that we use. So therefore, in the ratio, d, and then we're going to have d root 3, and then 2d. We cross off all the d's, and that leaves us then with 1, square root of 3, and 2. And this is another moment where it would be good just to let you know square root of 3 is about 1.732. Remember that the hypotenuse needs to be the longest side. So therefore, our ratio should be 1 to 1.732 to 2. A common issue that people have with this type of triangle is trying to remember then where does square root of 3 go and where does 1 go. Well, part of it is that in the picture, 1 is the shortest side, so 1 is always going to be there, the shortest side. And then the other leg has to be the square root of 3 because the longest leg was 2. So that's usually my recommendation when you're trying to label these triangles. Find the shortest side first, call that 1. Find the longest side, the hypotenuse, call that 2, and that requires square root of 3 then to go for the height. Okay, so in this question we have a semi-equilateral triangle, which that just means we have half of an equilateral triangle. I've already gone and broken it up for us here. It says the length of the shorter leg in a semi-equilateral triangle is 10. Find the length of the longer leg and the length of the hypotenuse. So the shorter leg we're told is 10, and then we're supposed to find the other two sides. So remember we have to label the three parts of our triangle now. The shortest side is always going to be the 1, so D is going to go down there. The hypotenuse is always the longest side, so that's going to be 2D. And then the last part is the height. That's the only one we haven't used yet, so that's going to be D root 3. One thing I forgot to mention as well that's going to be helpful, 30 degrees will always be across from the shortest side, and 60 degrees is always going to be across then from the longer of the two legs, because 90 degrees is the largest angle and it has to be across from the longest leg, or longest side I should say. So that's another way that you can remember if you're looking at these triangles. 30 is always across from the shortest side, 90 is always across from the longest, so 60 has to be across from square root of 3. Okay, now finishing this question then. We already know then that 10 is equal to D. Just because we labeled the triangle there. So that means then to find the longer leg, we just have to do 10 times the square root of 3. And then to find the hypotenuse, that is just going to be 2 times 10. And therefore, we get 20. And that's all we had to do. Okay, this one, we have to find the length of an altitude in an equilateral triangle with the side of length 10. So just as a reminder, the word altitude means height. So I'm just going to put an X there. That's what we're trying to find. Then we have to label the three parts of our triangle. So we know, once again, shortest side is going to be D. Hypotenuse is going to be 2D. And lastly, we've got d root 3 for our height. So in this case, we know that 10 is going to be equal to 2d. So if we divide both of those by 2, d has to be 5. And then to get our altitude, it's just d times the square root of 3. So therefore, our x will be equal to 5 root 3. And that's all we had to do there. Okay, so please pay special attention. This triangle is not oriented the same way as the ones before. So go ahead, pause the video, solve for the value of x. When you are done, start it up again, and I will show you how to do this question. Okay, now that you've done that, so I gave you a hint at the beginning. This triangle is now on its side, so we are not going to label it the exact same way as we did before. Remember that 30 degrees is always across from the shortest side. That's D. 90 degrees is always across from the longest side. That's 2D. And then the 60 degrees is across from D root 3. Now that we have labeled our triangle, we can go ahead and start solving it. The only information that we're given that will help us find D is 2. So we're going to start with 2 equals D root 3. We have to divide both sides by the square root of 3. And we get 2 over root 3 is equal to D. Let's rationalize our denominator here. So square root of 3 on top and bottom is going to be multiplied. And now we are going to have 2 root 3 over 3 is equal to D. Then for x, we're told that x is equal to 2 times D. So we just need to write x equals 2 times, and then we found D over here, 2 root 3 over 3. And then that will give us 4 root 3 over 3. That is the hypotenuse in this triangle. So the last thing that we're going to talk about then are the trig ratios for the 30, 60, 90 triangle. So we now need to talk about sine of 30 and sine of 60. First, sine of 30. So we're going to erase 60 there. This is going to be theta. So here's our opposite, here is our adjacent, and there is the hypotenuse. So we see then that this is going to be the opposite over the hypotenuse. We get d over 2d. Of course, d's will cancel. And it turns out that the sine of 30 is 1/2. Then we're going to do cosine of 30. We get d root 3 over 2d. Once again, we can cancel out the d on the top and bottom. And this one, oh, I canceled out the 2 there, sorry. There we go. And this time we will get square root of 3 over 2 for cosine of 30. And then the last one that we have is tangent, that is opposite over adjacent. And so we are going to have d over d root 3. D's cancel. We now have 1 over root 3. But we need to rationalize, so multiply the top and bottom by square root of 3. And so tangent of 30 is going to be square root of 3 over 3. Now we're going to do the same thing for the 60-degree angle. So we're going to erase our labels, and we have to relabel this triangle now. 30 degrees is gone. Actually, what I'll do is I'll change colors as well. So 30 degrees is now gone. And then we're going to have hypotenuse is still 2d, but this time the opposite is at d root 3, and d is going to be the adjacent side. So for sine of 60 degrees, we are going to have d root 3 over 2d. D's cancel. And this one is going to be root 3 over 2. And maybe you're going to start noticing a pattern here. Cosine of 60 is going to be d over 2d. Cancel out the d's. we are going to get 1/2. And then the last one that we are going to have, tangent of 60 degrees, oops, sorry, that is going to be opposite over adjacent, d root 3. Did I do the other one backwards? No, I did. I did not. I'm sorry. Sorry, I not thinking straight here. Okay. Tangent of 60 degrees, excuse me. Cancel out the d's, and then we're going to be left with just square root of 3. So that one doesn't quite follow the same pattern, but tangent of 60 is actually going to be the reciprocal. These are reciprocals of each other. And then you'll notice sine of 30 and cosine of 60 were the same. Meanwhile, sine of 60 and cosine of 30 were the same. There you go. So that takes care of everything. So here is the assignment. What I want you to do then, go to Schoology, look at questions that I've marked as required and which ones are optional. Thank you for listening, everybody. Have a good day.